Ya, Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
So, jadi hari ini kita adakan meeting untuk berbincang mengenai PBL kita dalam subjek medical instrumentation. Jadi ini adalah soalan dia. Jadi kalau kita lihat di sini, kita kena buat mengenai diagnose a human hand skin disease about Atopic Eczema, assessment known as the laser Doppler blood perfusion detection system for Atopic Eczema on human skin tissue. Okay, so ini tajuk kita. Jadi kita kena melantik beberapa orang untuk memegang jawatan sebagai chairman, team leader, cameraman atau camerawoman. Yang lain adalah sebagai participant lah. So next, ini adalah kita punya problem statement. Jadi sebelum kita pergi kepada problem statement kita lantik dulu siapa yang sudi untuk menawarkan diri untuk jadi chairman, team leader dan juga cameraman ataupun camerawoman. Jadi ada cadangan tak daripada rakan-rakan?
Saya nak cadangkan Zahir sebagai team leader.
Saya sebagai team leader.
Boleh tak?
Kenapa kita tak lantik perempuan yang sudi jadi team leader? Afifah ke? Team leader ataupun chairman?
Kalau perempuan jadi chairman, lelaki jadi team leader.
Perempuan jadi chairman, mungkin okey juga. Okey lah, fair juga kalau kita buat untuk orang cakap memegang jawatan yang tertinggi ni seorang lelaki, seorang perempuan kan.
Betul.
Okay, jadi macam Haikal kata tadi, chairman perempuan, team leader lelaki. Jadi siapa yang sudi jadi chairman? Syafiqah, okey jadi chairman.
Okey, setuju.
Setuju Team leader, Haikal tak sudi jadi team leader.
Saya nak jadi presenter.
Okey. Jadi kalau macam tu okey lah, saya terima lah. Saya sebagai team leader lah, macam yang disyorkan oleh para tadi. Okey. Jadi dalam kumpulan kita ada 6 orang, patutnya kena ada 7 orang. Dan grup yang kedua ada 7 orang. So kita kekurangan seorang lah. Jadi siapa nak untuk menjadi cameraman, camerawoman?
Saya nak cadangkan Syafiqah lah jadi camerawoman.
Syafiqah tapi dia dah jadi chairman, takkan dia jadi camerawoman juga? Macam mana tu?
Okay, sebab chairman dia tak perlu present soalan-soalan dalam problem statement ni. So saya cadang dia buat 2 kerja.
Okey, betul juga. Sebab chairman dia tak perlukan bentangkan problem statement ni kan. Okey. Macam mana Chairman? Syafiqah, okey ke buat dua jawatan, memegang dua jawatan?
Serius tak? Nak suruh jadi camera woman?
Boleh lah.
Nah,
Sebabnya kan?
sebab?
Sebab okey. Kita ada 6 orang. So jadi berdasarkan soalan ni ada 5 task kan. Jadi kalau 3 orang dah pegang jawatan, jadi kesian lah dekat 3 partisipan tu. Dia orang nak kena bentangkan 3 orang untuk 5 topik kan. Jadi kalau kita 4 orang bentang ataupun 5 orang kan, okey lah.
Faham.
Kan?
Kalau macam tu boleh lah jadi camera woman.
Okey. So seterusnya kita pergi pada problem statement. So jadi chairman dan cameraman adalah Nashika, dan leader dia saya, Zarif. Okay, jadi problem statement ni ialah a patient with atopic eczema had skin disease has been brought to the dermatology department of Kuala Lumpur Hospital. The patient is required to undergo standard operating procedure to monitor and diagnose the skin disease area. Based on dermatologist, consultants and experts' feedback, the patient has to undergo several diagnostic treatments for the recovery process, which includes skin patch test, prick test, intradermal test for biopsy experimental results. Those tests are usually irritating, harmful, inconvenient, and cause discomfort to the atopic eczema patient. So therefore, an accurate quantifiable assessment of laser Doppler blood perfusion detection system for atopic eczema on human skin tissue will help the dermatology expert and consultant to establish a realistic objective of treatment. Okay. So jadi berdasarkan problem statement ni, dan kita kena melakukan kajian ke atas new instrument, iaitu laser Doppler blood perfusion detection system. Adakah ianya sesuai untuk digunakan untuk penyakit atopic eczema on human skin tissue, atas kulit manusia? Ini adalah untuk menggantikan diagnostic treatment yang inconvenient. Okay, so jadi ini adalah 5 clue nya. Kita sebagai future technologist product specialist, berdasarkan clue ni kita kena explain possible instrumentation system, yang mana instrumentation ini adalah laser Doppler blood perfusion detection system. So jadi clue yang pertama adalah a constructive literature review of 10-year studies related to atopic eczema in skin tissue. Jadi untuk clue yang pertama ni, siapa yang sudi mengambil clue yang pertama untuk cari maklumat mengenai clue yang pertama? Okay. Siapa tu? Afifah. Okey. Jadi Afifah akan ambil clue yang pertama. Okay, seterusnya clue yang kedua ialah comparative between healthy human skin tissue structure and atopic eczema human skin tissue structure. Jadi ni clue yang kedua adalah kita kena buat perbandingan antara kulit manusia yang sihat dan juga yang mempunyai penyakit atopic eczema. Jadi wakil untuk siapakah yang sudi untuk mencari maklumat mengenai clue yang kedua?
Yang kedua ni kasih aku lah.
Okay. Siapa? Nur Syakina.
Tak ada Nur Syakina.
Okay, Syakina je. Okay. Seterusnya yang ketiga. Ketiga ialah block diagram and its description. With its description of the laser visible light which emit onto the atopic eczema area of interest of human skin tissue. Jadi ini adalah kita perlu mengeluarkan satu block diagram yang mengenai instrumentation, mengenai laser Doppler blood perfusion detection system. So jadi siapa sudi untuk mengambil clue nombor 3?
Ahmad Haikal.
Okay, baik, terima kasih. Okay, yang seterusnya clue yang keempat ialah Doppler shift effect within the atopic eczema human skin tissue under investigation. Okay, jadi ini kena siasat apakah efek, apa Doppler shift effect ni, apa benda dan apakah kaitan dia dengan atopic eczema human skin tissue under investigation. Jadi yang tinggal adalah Farabi.
Ya, boleh.
Jadi Farabi ambil clue nombor 4
Okay.
Baik. Okay, clue nombor 5. Using multi-simulation, multi-sim propose a complete circuit diagram for laser Doppler blood perfusion detection system. Jadi clue nombor 5 ni kita kena nyatakan satu circuit diagram yang lengkap mengenai laser Doppler blood perfusion detection system. Tapi 4 orang dah ada kerja kan, 4 orang dah ada, masing-masing dah ambil dah 1 sampai nombor 4. Jadi yang tinggal 2 orang, saya dengan Syafiqah. Tapi Syafiqah pun dah ada kerja juga, jadi chairman dengan camera woman. Jadi saya ambil lah clue nombor 5 ni, saya buat. Okey, jadi tempoh masa yang diberikan untuk kita buat finding atau investigation tentang clue yang telah diberikan pada setiap orang adalah sehari. Jadi keesokan harinya kita akan adakan meeting dan kita akan bincangkan tentang finding yang kita dapat. Okey, boleh semua?
Boleh.
Okey, baiklah.
Boleh.
Alright. Okey, Assalamualaikum warahmatullahi wabarakatuh semua.
Assalamualaikum.
Waalaikumsalam.
Jadi seperti yang kita dah bincangkan semalam, jadi hari ini adalah meeting bagi kita dapat masing-masing bentangkan keputusan ataupun finding masing-masing. Jadi untuk kita berkongsi sama kita sebelum kita teruskan pada pematangan. Okay, jadi untuk clue pertama, saya minta kepada Afifah untuk share screen, tunjukkan apa yang kamu dah jumpa.
Okey, saya share. Nampak tak?
Tak ada. Okey.
Okey. So saya jumpa satu artikel dekat Google. Yang ini 2016 mengenai atopic eczema. Ni ada gambar lengkap. Okey. Lepas tu saya ada jumpa dalam World Journal of Dermatology 2017. Ni dia ada tunjuk lengkap lah. Dia ada tiada cerita macam mana atopic eczema ni. Dan saya ada highlight juga sikit-sikit yang topik penting yang ini gambar ajar yang saya masukkan dalam report. Ini pun saya jumpa juga the structure of normal skin and the morphology of atopic eczema. Setakat ni, ini je lah saya jumpa.
Okay, terima kasih pada Nur Hafifah. Jadi saya percaya dia telah meng-highlightkan poin-poin penting dalam finding dia. Okay, seterusnya kita pergi pula kepada clue nombor 2, iaitu perbezaan mengenai kulit manusia yang sihat dan juga yang berpenyakit atopic eczema. So jadi saya jemput Syakinah.
Okay, untuk soalan nombor 2, saya jumpa jurnal yang ni tapi tak ingat dah link dia. Ini 2017 punya. Dia ada cerita lah pasal skin healthy dengan yang skin ada eczema. Lepas tu dia ada bagi structure untuk normal skin dengan skin yang affected by eczema. Dan dia ada cerita juga pasal perbezaan sel-sel lah yang skin healthy dengan skin yang ada eczema. So macam saya dah keluarkan lah yang poin-poin penting dia.
Tapi yang ni bukan sama dengan Afifah. Ini macam Afifah. Okay, tapi kalau kamu ada jumpa lah apa yang clue kamu tu.
Ada juga.
Kalau jumpa okey lah. Kita nak dia punya clue. Walaupun dia dalam
Memang sama lagi pun.
Okay, dalam artikel sama lah. Ada
Betul.
Okay. Maksudnya dalam artikel sama kita ada jumpa 2 clue lah.
Betul.
Okay, baik.
So yang ini je lah.
Okay, baik. Terima kasih. Okay. Jadi seterusnya kita balik pula kepada clue yang nombor 3, iaitu block diagram. Jadi saya jemput Syaikal untuk bentangkan apa yang telah kamu jumpa untuk clue nombor 3. Okey, jadi apa yang kita lihat kat sini Boleh unmute tak dengar.
Okay. Nampak?
Alright, nampak.
Nampak.
Okay. Yang ni saya Google dekat dapat daripada website ResearchGate. Senang sebab kalau tengok dekat sini pun banyak yang agak kompleks kan. So saya ambil yang paling simple and mudah faham. Sini boleh tunjuk flow daripada mana laser tu bergerak untuk sampai ke skin. So saya pilih block diagramnya untuk clue nombor 3.
Untuk block diagram ni tahun bila ada jumpa tak? Tu tadi 2000 berapa? 4
2004.
September 2004.
Yang 2004 ni macam lama sangat. Oh, ini yang tadi tu memang 2004 ke?
Search yang baru pun dia hampir lebih kurang je function dia, tapi ni ambil yang paling simple.
Alright, okay. Okay, itu saja ke?
Okay, itu saja.
Okay, baiklah. Jadi seterusnya, clue nombor 4. Apakah itu Doppler shift effect?
Alright, sekejap saya share screen boleh nampak tak?
Okay, boleh.
Macam kita dapat soalan berkenaan Doppler shift effect on human skin tissue under investigation. Jadi pada mulanya saya tak tahu apa maksud Doppler effect tu, so saya tengok YouTube je. Kalau tunjuk video okey ya? Boleh ya?
Boleh.
The Doppler effect. In Sheldon's words, it's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Doppler effect dulu.
The Doppler effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wavefronts bunch up, and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a high frequency. And if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect. The apparent...
Okay, so ni dia punya yang saya dapat dia maksud Doppler effect tu ialah apparent change in the frequency of a wave caused by a relative motion between the source of the wave and the observer.
Apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes sense, but it gets interesting when you consider some of its applications. And a car drives past you very, very fast. As it does so, it honks a horn because you're standing in the middle of the road. The horn to you might sound something like this. So it starts at a high pitch and moves to a lower pitch, even though from the driver's perspective, the horn is playing the same pitch the entire time. So what's going on? As the vehicle's coming towards you, the sound waves that it's emitting bunch up and so are delivered to you at a higher frequency, which you interpret as a higher pitch because the frequency of sound waves is pitch. And then when the vehicle passes you and is moving away from you, the sound waves spread out and so you hear them at a lower frequency, a lower pitch. So that's how the Doppler effect works with sound. It also affects another kind of wave.
So untuk yang berkenaan dengan laser Doppler effect dekat human skin tissue ni, saya tak jumpa yang serupa dengan soalan tu. Cuma saya jumpa yang macam ada ni
konsep lah.
Dia punya same concept lah. So dia cerita ni pasal blood flow monitoring with laser Doppler and spectral imaging. So laser Doppler ni dia boleh digunakan untuk blood flow mapping, untuk tengok flow blood tu dia bergerak laju ke ataupun perlahan ke. So dari situ kita dapat tahu lah orang tu ada sakit kulit ke ataupun berkenaan dengan penyakit kulit ke. So dia bagi kat sini daripada gambar ni berkenaan dengan laser Doppler imaging of blood flow in the patch test. Ini kalau yang hijau ni maksudnya dia no blood dekat situ. Kalau yang merah ni dia maksudnya ada blood lah kat situ. So saya
yang kuning tu tahu? Yang kuning tu apa?
Kuning tu
tak tahu, tak jumpa lagi.
Tak jumpa.
Okay, alright.
Lepas tu saya masukkan dalam report saya untuk present nanti.
Jadi itu saja kan?
Itu saya.
Baiklah. Terima kasih saya Farabi. Okey, jadi kita pergi pula kepada clue yang terakhir, yang kelima, iaitu kita kena buat simulation dalam multisim. Jadi untuk clue nombor 5 ni saya akan share screen saya. Jadi kita kena propose a complete circuit diagram for laser Doppler blood perfusion detection system dalam multisim. Jadi setelah saya cari di Google, jadi saya rasa adalah yang terbaik, iaitu constant current laser diode driver. So ini ialah circuit untuk driver, iaitu laser diode driver, yang mana ia menggunakan operational amplifier 2350. Okay, jadi seperti yang kamu boleh nampak, jadi ini adalah dia punya driver dan ini adalah laser diode dia. So ini adalah dia punya schematic diagram ataupun circuit diagram. Dan ini adalah detail part list. Kita boleh nampak kat sini ada quantity, ada parts number, description. So jadi saya percaya melalui schematic ni saya boleh membuat simulasi di dalam software multisim. Jadi dalam multisim tu kita boleh lihat dia punya keputusan, iaitu dia punya signal. Kita akan letakkan probe, iaitu probe oscilloscope kat dia punya output. Mungkin kita boleh letak 4 probe yang mana akan mengeluarkan 4 signal output pada point-point yang berbeza. Okay, jadi kita kat bawah ni ada video yang mana bagaimana driver ni berfungsi dan bagaimanakah laser yang dihasilkan. Jadi pendek saja, kita akan tengok sekejap. Jadi voltage adalah 3.4 volt. Supply voltage. Dan ini orang ni dia control potentiometer ataupun variable resistor. Jadi kita boleh lihat intensity laser yang dihasilkan, iaitu semakin mengecil dan kembali besar semula. Okay, jadi berdasarkan video ni, video yang kita lihat tadi, jadi saya percaya circuit ni adalah circuit yang bagus lah untuk saya melakukan simulasi di dalam software multisim. Okay, jadi itu saja daripada saya. Okay, terima kasih pada semua partisipan yang telah membentangkan clue masing-masing. Jadi saya harap pada hari pembentangan nanti masing-masing menyediakan satu dokumen ataupun report yang lengkap untuk dibentangkan pada hari pembentangan, agar audiens dapat memahami secara sepenuhnya apa yang cuba untuk kita sampaikan, iaitu daripada clue yang pertama sampai clue yang kelima yang kita akan bentangkan, iaitu berkaitan dengan kita kena mencipta ataupun propose satu possible instrumentation iaitu laser Doppler blood perfusion detection system untuk penyakit atopic eczema ke atas kulit manusia. Jadi itu saja. Jumpa anda semua pada hari pertanyaan. Okay, terima kasih.
Thank you.
Okay. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. Before we start, I would like to introduce myself. My name is Nur Syafiqah Nadia binti Sabarudin. As the chairwoman and the team leader is Nazrul Zarif bin Zulkifli. Next, the participant consists of 4 people which are Nur Afifah binti Abdul Aziz, Shakina binti Muhammad Razif, Ahmad Haikal bin Muhammad Syahrul Munir, and lastly Farabi Ashraf bin Mahzan. So now we move to the presentation. Let's start with the problem statement given, which is a patient with atopic eczema, hence skin disease has been brought to the dermatology department of Kuala Lumpur Hospital. The patient is required to undergo standard operating procedure SOP to monitor and diagnose the skin disease area. Based on the dermatologist, consultants and experts' feedback, the patient has to undergo several diagnostic treatments for the recovery process, which include skin patch test, skin prick test, and intradermal test for biopsy experimental result. So those tests are usually irritating, harmful, inconvenient, and cause discomfort to the AE patients. So therefore an accurate, quantifiable assessment of laser Doppler blood perfusion detection system for atopic eczema and on human skin tissue would help the dermatologist, expert and consultants to establish realistic objective of treatment. So the main point is how we went to help the patient with the atopic eczema by using laser Doppler blood perfusion detection system. Before I pass to the team leaders, I have one quote to the team: the ways to achieve your own success into willing to help somebody else get it first. So now you may proceed the presentation about problem statement, and I will pass to team leaders. Thank you.
Thank you, Chairman, Ms. Nur Syafiqah, for the explanation on the problem statement. Therefore, we as a team of future technologist product specialists are required to do research on how we want to solve the problem. It might replace the patient treatment from undergo several diagnostic treatments to by using laser Doppler blood perfusion detection system for atopic eczema disease. Now, I would like to highlight 5 important clues which may assist us solve the problem statement. So clue number 1, that we need to know a constructive literature review of 10-year studies related to atopic eczema on human skin tissue. Clue number 2, what is the comparative between healthy human skin tissue structure and atopic eczema human skin tissue structure? Clue number 3. We must find the block diagram and its description, or an ideal illustration diagram with its description of the laser visible light which emit onto the atopic eczema area of interest of human skin tissue. Clue number 4. What will happen when Doppler shift effects within the atopic eczema human skin tissue under investigation? And clue number 5. We have to propose a complete circuit diagram for laser Doppler blood perfusion detection system by using multi-simulation, which is multi-sim. So let us proceed with the discussion. For the first clue, I would like to invite Ms. Nur Afifah to conclude her finding on the literature review of 10-year studies related to atopic eczema on human skin tissue.
Thank you, Mr. Nazrul. I'm going to share my screen right now. Can you see my screen?
Yes, Afifah, we can see.
Okay, okay. So my part, I'm going to focusing on literature review of 10-year study atopic eczema human skin tissue. So basically, atopic eczema, also known as atopic dermatitis, is an itchy inflammatory disease where the skin barrier has become leaky and inflammation happen. So this eczema typically starts in infantry or early childhood. Every year, it acts up to and out, which is resulting as red itchy patches of PBC. So this eczema likely caused by combination of factors, genetic, environmental. Disease include as rough fabric in contact of the skin, such as patch wool, cigarette smoke, and extreme heat or cold. And the side effect will come with asthma, food allergies, and allergic rhinitis. This inflammation happen when the immune system attacks the skin, causing the skin start to become dry, itchy rash on the flexor surface area like the crease of the wrist, inside of the elbow, the back of the knees, as well as the skin surface like the face, hand, and the feet. This process called hypersensitivity reaction. In 2010, WHO article into the global burden disease, this eczema was ranked first by causing the greatest number of days that people were not at full health. This referring to the asthma, food allergy, and also the allergic rhinitis. We can't treat. There's no cure for this eczema, but this eczema can be treated. So we're going to talk about the human skin tissue. So in this picture, the left picture is the healthy skin, and the right picture is the skin affected by the eczema. We can see here the red dot is a germ, and the blue dot is actually lipid speck, also known as the moisture of the skin. Okay, so it will become rough, cracked, virtually inflamed skin due to damaged skin barrier. Okay, so we all know that the skin is the largest organ of the body, and it plays several key roles in survival. So it's protecting the body against the entry of the allergen and virtually retaining water within the body. The skin is composed of three main layers, which is epidermis, outer layer, dermis, middle layer, and hypodermis, inner layer. So the outer layer, epidermis, has different layer too, which is the basal layer, the spinous layer, lipid, and the corneal layer. You can actually see the graph, the picture here. So the corneal layer is the most up layer. This is the visible part of the skin, and the function is to protect the body from the germ. And the lipid, the fat, is regulate hydration and help defend the skin from foreign invader, either indirectly through immune signaling or directly through their inherent antimicrobial activity. The spinous layer is the next layer, consists of 8 to 10 layer of cell, which the cell shrink slightly during fixation and tightly bound to each other. The basal layer, the bottom layer, is the single layer of cell which constantly move up to the top where they are lost. This means damaged cell are continuous shape and it renews itself constantly as new cell. When skin affected by this eczema, the corneal layer does not provide enough protection because it's damaged by the inflammatory response occurring in the skin. Other possible is caused by a mutated gene that affect the production of the protein filaggrin, which the body needs to make skin outer layer. If the filaggrin is not enough, the balance of fat in the skin changes, causing the skin to lose the moisture, and the damaged skin wall causes the skin less protection from the irritation, allergen, and germs that might cause infection. So this is the reference. I take the reference within the 10 years. Okay, I found 3 reference. So this is the reference. That's it for my part.
Thank you, Ms. Afifah, for the great explanation for the first clue. So now I would like to invite Ms. Shakina to share with us about the second clue, which is the comparative between healthy human skin tissue structure and atopic eczema human skin tissue structure.
Okay, thank you, Nazruzari. Can you guys see?
Yes, sure, we can see.
Okay, I will explain about comparative between healthy human skin tissue structure and atopic eczema human skin tissue structure. Okay, the normal skin consists of the epidermis, papillary and reticular dermis, and the subcutaneous fat. The epidermis is the outermost layer of skin, provides a waterproof barrier and creates our skin tone. The dermis is beneath the epidermis, contains tough connective tissue, hair follicles and sweat glands, and the deeper subcutaneous tissue, which is hypodermis, is made of fat and connective tissue. Okay, for eczema, the dermis or innermost layer is responsible for providing structure and support to the skin. Eczema is believed to arise when the body's immune system is triggered into an abnormal overactive inflammatory response that involves both the epidermis and the dermis. Based on the schematic diagram, here is the skin of a normal person and the patients of atopic eczema. Okay, for healthy human skin tissue, first is the epidermis. The most superficial of this is the horny layer or stratum corneum, which on the skin of the forearm is composed of several laminated and loosely attached layers of anucleic keratinous cell. The granular layer is composed of 2 to 3 tightly opposed cell layers that contaminate deeply blue staining keratohyalin granules. The squamous layer consists of 5 to 7 layers of polyhedral cells attached to each other by intercellular bridge that contain desmos. The basal cells that lie along the dermoepidermal junction are cuboidal or columnar cells that contain blue-gray filamentous apparent material and are attached to each other and to the overlying squamous cells by intercellular bridge. Second is the supraepidermal basement zone. It is the variable size cellular processes of the basal cell interdigitate with this zone and the papillary dermis. The normal basement membrane zone appears as a thin, variable dense like pale green area along the dermoepidermal interface. Third is the dermis. It is composed of collagen fibers that are randomly dispersed but which do not interlace. The papillary dermis attaches irregularly upwards as purge or papillae which interdigitate with the red ridge. The irregular columns of epithelium that project downward. Okay. The fourth is the reticular dermis. Is composed of variable size bundles of collagen fibers that interlace irregularly. Variable numbers of fibroblasts are scattered among these bundles. The collagen fibers of the reticular dermis appears closely opposed in I negative UM thick sections and do not exhibit the artificial separations characteristic of the paraffin embedded tissue. And the last one is the subcutaneous fat. This is arrayed in lobules delimited by collagenous septa whose fibers arise from the lower reticular dermis. For eczema, the skin is composed of two layers, which is the epidermis and the dermis. The epidermis is the outer layer that acts as the body's primer defense against the environment. The dermis or innermost layer is responsible for providing structure and support to the skin. Second is the lichenified plaque, hyperkeratosis, psoriasiform hyperplasia, and dyskeratosis of the epidermis were noted in the 5 biopsy specimens. In 3 specimens, there were varying degrees of intercellular edema and slight infiltration by lymphocytes was observed in 4 specimens. A moderate cellular infiltrate containing predominantly monocyte as well as lymphocyte was present in both perivenular and intervascular locations. In several lesions, the SCV exhibited similar but less marked changes. Next is the changes in atopic eczema in I negative UM thick sections exhibit both similarities to and differences from those observed in allergic contact dermatitis. In allergic contact dermatitis, the changes in venules are noted only in relation to prevenular lymphocytes curve, whereas in atopic eczema they occur without and with a surrounding infiltrate. Last but not least, the venular endothelial cells in atopic eczema. The alterations of venous in the absence of an inflammatory infiltrate in lesional skin may reflect local involvement or alternatively a widespread underlying disorder. It is also consistent with quantitative determinations of increased levels of tissue histamine in chronic lesionophyte plaques. And the last one is the cutaneous myelinated nerve. These nerve changes were not associated with cellular infiltrated in view of venular changes. The possibility of an ischemic mechanism must be considered. The derangement of neural structures may be related to the symptoms, especially since mast cells contains mediators capable of eliminating pruritus. That's from me.
Okay, thank you, Ms. Shakina, for the impressive sharing about the second clue. Now, for the third clue, I would like to invite Mr. Haikal to present his discovery on an ideal illustration diagram with its description of the laser visible light which emit onto the atopic eczema area of interest of human skin tissue.
Okay, thank you, Mr. Zarif. Okay, I will proceed with the presentation. Okay. For the block diagram, there have been several description about the block diagram, which is the scanning mirror laser, signal processing, photo detector, and computer. Okay, for optical method from the near infrared range, in particular the laser Doppler fluorometry and the near infrared spectroscopy offer a new non-invasive real-time technique for monitoring of the blood perfusion and oxygenation in a living tissue. The advantage and limitation of this technique are also discussed, and new trend in technical development of the laser Doppler fluorometry and the near-infrared spectroscopy, especially contactless perfusion scanning and photon time of flight measurement. Okay, I will go through the description.
Can you
Yes.
zoom? Can you zoom the document?
Alright.
Zoom a little bit. Okay. Okay. Thank you.
Alright, thank you. Okay, for scanning mirror, most laser scanner use movable mirror to steer the laser beam. The steering of the beam can be one-dimensional, as inside a laser printer, or two-dimensional, as in a laser show system. Next is a laser. Laser are medical device that use precisely focus light source to treat or remove tissue. The term laser stands for light application by stimulated emission of radiation. Ordinary light, such as that from a light bulb, has many wavelengths and spread in all directions. Laser light, on the other hand, has a specific wavelength. It is focused in a narrow beam and create a very high intensity light. Because laser can focus very accurately on tiny areas, they can be used for very precise surgical work or for cutting through tissue in the place of a scalpel. Okay, next is for signal processing. Signal processing is a digital signal processing. Is the processing of digitalized discrete time sample signal. And for the photo detector include any device for registering photon with frequency above that of a radio wave from far infrared on up to gamma rays. Okay, next I will go for laser visible light. So for laser visible light, eczema treatment are creams or ointment that reduce itch and redness, apply directly to the skin. If these are unsuccessful, systemic medicine that affect the whole body or phototherapy are the options. And phototherapy or light therapy or visible light therapy can be used ultraviolet UVA or photochemotherapy UVA, where phototherapy is given alongside substance that increase sensitivity to the UV light. That's all from me.
Thank you, Mr. Ekal, for the admirable discovery on the third clue. So we move to the clue number 4, which what will happen when Doppler shift effect with the atopic eczema human skin tissue under investigation. With that, I would like to invite Mr. Farabi to fill us in detail about the effect.
Okay, first of all, thank you to Mr. Zarif, my team leader and my team members for a very well explanation on the PBL. My name is Farabi and I am going to present the Doppler shift effects, which is part 4. Doppler shift effects within the atopic eczema on the human skin tissue. I will share the screen. So first of all, what is a Doppler shift effect? A Doppler shift effect can be defined as the change in the frequency of wave caused by a relative motion or a movement between the source of the wave and the observer. Some of the real life application of Doppler shift effect can be seen through an example of an ambulance and a stationary person where in this situation the ambulance emits sound wave in the form of a siren. As the ambulance moves towards or closer to the stationary person, the frequency of the sound wave will become higher, and as it moves further away from the stationary person, the sound waves are observed at lower frequency. Therefore, the person who is nearer to the source of the wave will experience higher pitch compared to the person that is standing away from the source. The same concept is being used in laser Doppler blood perfusion, where the laser is used instead of sound waves. The laser which emits from the laser beam is separated into two separate beams and passed through a converging lens. These two converging lenses will eventually intercept each other, and they will form fringes, which is defined as shifting bands of bright light. When an object passes through these fringes, it will be going to reflect the light, and since we use the laser Doppler blood perfusion, it is the red blood cell that will passing through these fringes. Whenever the red blood cell passes through the fringes, it will form a light burst. Depending on the velocity of the red blood cell, the intensity of the light burst will vary at each straight fringes. A photodetector is being used to measure the change in this light burst, which then gives us the result of velocity of the red blood cell. The physical distance between the fringes is known from the calibration which is performed with every probe. Therefore, the frequency of the intensity signal is directly proportional to the velocity of the particle. We can see here, based on the figure 5, the frequency of the sinusoid is known. Thus, the speed of the particle can be calculated by using the formula of speed, which is equal to fringe spacing times frequency. As for the laser Doppler blood perfusion, this assessment features typically visualize and this method features visualize and nervous sikit.
Relax Harabi. Tarik nafas.
As for the laser Doppler blood perfusion, this assessment features typically visualized and as for the laser Doppler blood perfusion, this assessment features typically visualized and imaging time in the form of color-coded perfusion image that reflecting the blood flow level or velocity. And in this practice, the blood flow measurement can be applied to patch testing, which is used to diagnose contact allergy. The test is conducted to mimic
allergic contact dermatitis by responding the triggering type of the reaction to a contact allergen.
Thank you, sir.
Okay.
So I continue. Based on figure 6, the image shown is the laser Doppler imaging of blood flow in a patch test. The color scale that which range from the smallest and largest value, which is from green to red, and usually patient with skin disease tend to have smaller value, which we can see in this image. The blood flow is very.
Next, the patient with atopic eczema tend to have smaller perfusion value as blood flow across the skin is limited compared to normal skin.
Thank you, sir. Sorry.
That's all from you?
That's all from me. Now I will pass back to Mr. Zarif, my team leader.
Okay, thank you, Mr. Farabi, for your excellent presentation about the clue number 4. So at last, for the clue number 5, I will explain to you about the complete circuit diagram for laser Doppler blood perfusion detection system. However, there will be no simulation as many components could not be found when I'm trying to construct the circuit inside multi-sim simulation software.
Excuse me, Mr. Zarif.
Yes.
I believe we can download the components from the internet and import those components library into the multi-sim simulation software. So why don't you do that?
Thank you, Chairman, for asking. Yes, I did try to create the non-existing component inside the multi-sim, but there are many steps to follow. In the middle of those steps, it requires model data of the component that I try to create, and I could not find the model data on the internet, so that hindered me from doing the simulation. But later on, I believe we can figure it out together to solve this simulation issue. Okay, I hope that explained. Okay, now allow me to share the screen for the circuit diagram of laser Doppler blood perfusion detection system. Can you see the screen?
Yes, we can.
Okay, so I will present in the word form. So this is the circuit diagram for the laser Doppler blood perfusion system. Okay, to make it easier for you to understand, I will divide the circuit into 3 sections. So the first section is the power management section. The second section is the temperature section, and the third section is the laser and light detector section. Okay, so now we move on to the first section, which is power management section. So for the power management section, it is divided into 2 parts. So the first part is supply, and the second part is regulator. So the supply will feed 5 volt to the regulator, and the regulator will output 3 volt. So the component used for the regulator is the voltage regulator TLV 713. So why we use this component is because it is to ensure a stable voltage level with lower risk of noise. And it has a fixed output voltage which is 3 volt, and it is enough to supply voltage for the components on the PCB. So now we will move to the second section, which is the temperature section. Temperature section will consist of 2 parts. So the first part is temperature measurement, and the second part is tissue heater. So now, as you can see here, there is 2 blocks here, the temperature block and temperature safety. So actually both of these is the temperature measurement, and the heater is the tissue heater. Sorry, yes, the tissue heater. So now we move to the temperature block. Now there are 2 identical components here, which is LM20. So this component is known as temperature sensor. So why do we need the temperature measurement? So the temperature measurement is designed to turn the heater off if it is exceeding 46 degrees Celsius. So whenever this heater is above 46 degrees Celsius, it is automatically off because the temperature sensor will detect. Okay, so next, why there are 2 sensors are used for the temperature sensor? It is because 2 sensors are used for safety reasons to compare the result. Okay, the value from both of these temperature sensor, it will fed into the comparator, which will compare the 2 value of this temperature sensor. So the comparator we use is, the component of the comparator we use is this ADCMP 361. Okay, now we move to the heater. So this is the tissue heater. So to heat the tissue, resistors and transistor will act as heaters by generating power. So second is to monitor the heater. The voltage at pin 12 is measured over resistors R11. So as you can see here, this wire is connected to the pin 12, and there is resistor 11 here. So both of them is used to monitor the heater. And this the entry. Let me zoom. So there is a transistor here, entry. So what is the function of this transistor? Okay, so a transistor entry, it used to control the amount of current in the circuit and generated power in the components. So basically that is the function of the temperature section. So now we will move to the third section, which is laser and light detector. So in this section also, it is divided into 3 parts. First is the laser Doppler, second is amplification, and third is the filter. So if you can see here, there is a component here. It says the name is Kyocera. It's from Kyocera. So the component we use is the Kyocera CRC 3.3. It is a combined vertical cavity surface emitted laser, or named as VCSEL, and photo detector. In this circuit also, there is a high noise frequency filter and low frequency filter. Okay, I will show you. So the filter at the anode of the laser is to filter out high frequency noise, using LC filter rather than RC filter to avoid the voltage drop over a resistor. So the component of the LC filter is, the code is this, the code. And for the low pass filter, the capacitor for the low pass filter is C8, which is set to 47 microfarad. So basically, this L1 is the component for the noise, for high frequency noise, and this C8 47 microfarad is the low pass filter. Okay, next we move on to the light detection. So the current from the cathode of the photodetector is amplified with the current amplifier, and then lastly is the anti-aliasing filter, which is the signal from the photodetector consisting of the blood flow signal is filtered with an anti-aliasing filter. So just now, the laser Doppler gain the signal, and then the signal will pass to the ADPD 210, which it will amplify the signal, and then it will pass the signal to the filter the signal, and then the signal will be transmitted back to the board. So if you are wondering what is this pin header, so actually pin header is this board PF6010 module. So this is the pin header, the black one. Okay, that's all from me. I hope you can understand the circuit diagram, which is, it starts from the power management section, and then we'll move to the temperature section, and then lastly is the laser section. Okay, thank you. Now I think we can move on to the Q&A session. So for the first round, our group will ask question to another group, and then for the second round, the group 2 will ask the question to our group. So I will open to the participant to give your question to the audience.
Kita buat the other way around, Mr. Zarif.
Oh, so the group 2 will ask the question first. Okay. I invite anyone from group 2 to ask the question to our group regarding our presentation on the PBL. So please.
Hello, Assalamualaikum.
Waalaikumsalam.
Waalaikumsalam.
My name is Khairul Zikri from Group 2. Okay, I have a question. Okay, my question is, what are the symptoms of the eczema?
Zarif, siapa daripada grup you yang catik soalan tadi? Kena ada seorang catik.
And no Shafika, maybe. Okay, not.
Yes. What the question say?
Can you please repeat the question?
Okey lah, tapi kalau yang ni tidak mungkin kita
Group 2.
Wait. Wait a minute. Okay, I change the question. Okay. My question is, what happened to the skin if someone affected from the atopic eczema?
Okay.
And if the atopic eczema can be cursed, give a reason why.
So for the answer, your question is the person will suffer from symptoms such as dry, inflamed, and very itchy skin with open sores. So no atopic eczema can be cured, but it can be treated using medical creams to reduce the dryness of the skin. It's the answer for your question just now. So for from another group too, one ask a question.
Assalamualaikum. My name Afifa from group 2. I have one question related to circuit diagram. My question is, why is it necessary to put the heater on the circuit diagram? That's my question.
Okay, thank you for asking. So why is it necessary to put the heater on the circuit? So the answer is that because since we are treating the skin, so by heating the skin while measuring blood flow, the viability of the tissue and degree of microscopy impairment can be determined. So the probe for PF6010 is heating the tissue to 44 degrees Celsius, and the temperature is monitored to avoid risk of burning the patient. So we need the heater is because it is more efficient to scan the skin with the heater. It increases the efficiency for the laser and the photodetector to detect. So I hope the answer satisfied you.
Okay, thank you Zarif for the explanation.
Assalamualaikum. I have a question regarding the laser blood perfusion. Okay, so how speed is measured in laser Doppler blood perfusion?
Okay, thank you. So the question asks regarding how speed is measured in laser Doppler blood perfusion. So the fringes is formed by the interference of the beams when a particle passes through the probe volume. It goes through the light and dark regions. So if it's reflected light is measured as it travels along, the intensity versus time curve looks like a sinusoid. Sinusoid is the physical travel of the particle through the fringes, and the physical distance between the fringes is known from the calibration which is performed with every probe. So the frequency of the intensity signal is directly proportional to the velocity of the particle, and given the formula of the speed, which is speed equals to fringe spacing times intensity frequency. That's my answer. Thank you.
Okay, got it. Thank you, Farvi, for the answer.
Yeah, I would like to add that one as well. It is better that you include the formula as well in your documentations as part of your finding. Kena ada tu. Alright. So berapa soalan? 3 soalan cukup lah tu ya. So siapa tak tanya soalan tu kan tak dapat lah markah. So I catat nama-nama yang tanya soalan dan yang jawab. Ada pemarkahan juga as I did mention last time kan. Okay. Tak apa, mana yang tak ada nanti you tanya soalan pula kan. Let's say now your group receiving questions from the second group. So nanti mana yang tak ada tu, the first group tanya soalan, okay, to the second group, so you ada marks for that. Alright. Okay, so untuk yang tanya ada soalan, untuk yang menjawab, untuk yang tanya ada soalan pula, untuk yang tanya soalan ada markah. Those who answer the questions also receiving marks as well. Okay. So nanti to be fair to everybody, nanti you all take turn lah. You all take turn lah. Okay. Alright. So chairman, mana chairman group tu? Question. Chairman kena tanya. Chairman group tu.
Right, sir. Sekejap I did prepare a question, but let me
Alright.
search.
No problem. Take your time. So nanti Syafika kena prepare question for the second group.
Okay, can.
Alright,
Okay.
here's the question.
Alright, proceed.
Atopic eczema can mimic other skin diseases and infections. Is this true or false?
Can you repeat again?
Okay, the question is atopic eczema can mimic other skin disease and infections. Is this statement true or false?
You boleh bagi jawapan ni kepada you punya team. Yang mana yang tak jawab lagi, kalau dia nak lah. Up to you lah. You all control.
Okay lah, I answer, okay. So for your question, is it true?
Yes. Wait, why don't I give you another question, because it seems quite tough. So I repeat, another question is, what happens if you don't treat eczema? Sorry, there was a long pause for me. What happens if you don't treat eczema?
Okay, so for the answer is, as atopic eczema can cause your skin to become cracked and broken, so there's a risk of the skin becoming infected with bacteria, and the risk is higher if you scratch your eczema or do not use your treatment correctly. So signs of a bacterial infections can include fluid oozing from the skin.
We'll see. Right, thank you.
Okay, welcome.
I got it. Thank you.
Okay,
so should we continue with my team?
Okay, hold on a second. Not bad lah answer tu. Kan? I pun suka cara answer tu. Which is good. Alright. So congratulations. Congratulations to those who give questions to group 1 from group 2. Alright, congratulations those who give questions, those who provide questions, and thanks to those who answer these questions. Okay, excellent. So there is still a opportunity for group 1 to ask questions to group 2 for you to seek marks as well, because yang tanya soalan, jawab soalan ni ada markah dia. Memang ada markah dia. Okay, I reserve the marks. Okay, I got one question. Alright, based on the task given, ini mungkin kena pada Mr. Zari lah, kita suka class rap, kita tanya class rap lah. Alright, based on the task given, well, you should be able to demonstrate the circuit in the simulation base. You can apply the multi-sim as requested in task. Kalau katakanlah multisim is not there, is there any options for you to use other than multisim? Ada tak? Tak ada.
Yes sir, actually there is an option because the finding that they have found the circuit is actually they use the LT Spice, but I also have tried downloaded the LT Spice, the software, but then again when I try to search for the component, still I cannot found the component inside the LT Spice software, so that's why.
Okay, other than the one that you have presented, is there any other simplest circuit that you have found that you came across during your research?
Wait, let me check first. There are a few circuits that I come across.
Sebab ada banyak kan you surfing the internet, there's a lot of circuit for the laser Doppler perfusion system, from the simplest to the complex kan. So, kita try tengok, what do you have?
Wait.
And then kita boleh start lah, lepas ni kita boleh start pula second group, get ready ya. Farabi, tengok muka Farabi macam ada seorang artis. Apa nama artis tu? Lupa lah nama dia. Dia tanya my wife, apa nama artis yang suka makan tu? Artis yang suka makan tu, siapa nama dia? Perempuan tu? Izrin.
Lelaki ke perempuan sir?
Perempuan. Kalau tengok dia berlakon, dia kuat makan je kerja dia. Perempuan Izrin. Muka macam you lah, muka. Izrin apa nama dia? Azrina. Izrin Azminda. So siapa tu suka tengok drama guys, suka tengok drama lah. My wife suka tengok drama, pun join lah. Okay, Zari dapat. Izrin Azminda.
I believe the most detailed circuit that I found is the one that I presented just now.
Okay.
Also other circuit, but no, they are not very detailed.
Well, the one that you find is it is schematic diagram. It's not schematic. It's a circuit. It's a schematic diagram, which is very detailed, right? So might be able to simplify it, but since that is the one that you achieve, if you can, before you submit the report, if you can try to simulate part of it, that will be great, especially on the laser Doppler part, as well as the amplifier and the filter part. Okay, because that is the most important part based on the topic given, right? Well, that we are really looking for the 20 marks tu. Rugi tu, tak ada multisim. Come on. Yang lain marks tu ada. So try to work on the 20 marks. This is quite high, you know. Rugi tak masuk kan. Alright. So anyway, try to simulate from the laser Doppler part to the amplifications as well as the filter. I believe it is there in the multisim. Alright. Try